So after getting this state table, so then find out the state diagram. So already we know the last step after finding the state table, so then we'll go with the step 5 is step diagram. No, so now we will implement that state diagram. So first of all, before going to draw the state diagram, first we'll see what is meant by state diagram. Okay, so state diagram is nothing but which information is available in state table. Okay, so whatever the information, which information is available in state table, so that information can be represented in graphical notation, that is called as the state diagram. Okay, so in this state table we are having some input information as well as some output information. No, so that is nothing but in state diagram the states is nothing but here we are representing the input values. Input values is nothing but whatever the present state you are having, like 0 0 0 1 1 0 1 1. No, those are called as the states. Okay, so in this state diagram each state is represented by a circle, and the transition between one input to the another input, that means transition between means from one input to the another input, that transition is indicated by the direction lines and connecting through the connecting of circles. So now I will show that first state diagram. So what is meant by state diagram? States are represented by a circle notation. So how many states we are having? Totally 4 states. All states represented in a circle. No, 0 0 0 1 1 0 1 1. So how to draw the state diagram means it doesn't have any shape, it doesn't have any symbolic notation. Okay, now so that is nothing but particular shape, it doesn't have it. Okay, that's your wish. You can draw like a straight line, or you can draw like a square box, or you can draw like a rectangular box. That's your wish. Okay, so just represent the input lines, whatever that input states you are having, that will be represented in a circles. After mention that states, okay, after mentioning that states, you can represent it the transition between from 0 0 to 1 0 or 0 0 to 1 1 or 0 0 to 1 1, whichever the transition you are having in transition table or state table, like this 0 0 to 0 0 0 1 1 1, like that. So in between two states, whatever the transition you are having, that will be indicated by directed lines through the connecting of circles. Okay, so that is the first point. And after that, the state diagram provides the same information as the state table. Okay, how to draw the state diagram means whichever the information we are having in state table, they are directly represented in state diagram. Okay, so the same information as the state table and is obtained directly from the table only. Okay, so the binary number inside each circle identifies the state of the flip-flop. Remember that one. So that is called as the state diagram. So now already I explained the state diagram, so we have to move on to the state diagram. So that is nothing but transitions, we should place it. So first transition started from 0. So the present state 0 0, whenever the input x value is 0, in that case next state what is that we are getting? Again AB value will be 0 0 only, the output value 0. So that means input x value is 0, output y value will be 0 whenever the transition will reaches the 0 0 to 0 0. So that means 0 0 to 0 0, the first transition, you can place it like this. 0 0 to 0 0 is nothing but that itself only we are having, right? So the transition itself only we are having, but which transition this is means whenever the input is 0 and the output is also 0. So you should maintain, after maintaining the directed line, that means after mention the transition between each state through the directed lines, so then the above of transition line or the beside of transition line, you can mention the input value and output value with the help of one slash. So before the slash, that means left side slash you can represent the input value, right side slash you can after the slash right side part you can mention the output part. So this is the output and this is the input, remember that value. So this is the first transition is completed. Now coming to the second transition, again AB value 0 0, the next state we are getting the 0 1, whenever the x value reaches 1, and the y value reaches 0. So that means 1 by 0 we are getting the transition is 0 0 to 0 1 state. So where is the 0 1? Here. So that means the transition between from present state 0 0 to next state 0 1, in that the input value will reaches as x will be 1 and the output will be 0. So 1 slash 0 you can represent. So 1 slash before is input, after slash is output. Okay. So first one is completed. Now coming to the 0 1 transition. So 0 1 transition is reaches as next says 0 0, but the input value is 0 and the output value is 1. So 0 1 again reaches the 0 0 transition. Okay, 0 1 reaches the 0 0 transition. The input value is, what is that? 0 1 transition is 0 0, the input value is 0 and the output value is 1. So you can represent 0 by 1. Input 0, output is 1. Next, what is the next transition from 0 1? So 0 1 next transition is whenever the x value is reaches 1. So then the next state it reaches to the 1 1 and the output is 0. That means it reaches the 1 1 state and the input is 1 and the, what is the output value here? Input is 1 and the output is 0. Okay. So 0 1 transition also completed. So 2 transitions completed from 0 1. Next we will go with the third state, that is 1 0 state. So 1 0 state will reach us whenever the x value is 0, it reaches the transition is 0 0 state, but the output value is 1. So 1 0 to 0 0 transition. So 1 0 to 0 0 transition, and the input is what and the output is what in this state? That is input is 0 and the output is 1. So 0 by 1 we should mention here above the transition line. So that is the 1 0 state. Now coming to the next transition of 1 0. So 1 0 transition, it reaches the next state value 1 0 only. That means itself only. Same value, no? So but the output value and input values will be 1 by 0. So itself, no? That's why I can represent like this itself, 1 0 to 1 0 only. So the input is 1 and the output is 0. Once again verify that input and output values 1 and 0 and 1 0 only. Clear. Now last state 1 1. So 1 1 state reaches to the 0 0. The input is 0 and the output is 1 1. Okay. So 1 1 reaches the 0 0 state. So 0 0 here we are having, no? So you can draw like this. Okay. So what is the input? 0 and output is 1. 0 by 1. And the last one is 1 1 again reaches the 1 0, but 1 0 output. So 1 1 transition goes to the 1 0 state and the input value is 1 and the output value is 0. So this is the state diagram representation. So that means what we will do, what we did here. So whatever the state diagram state table represented, that means which information is available in state table, as it is we can represent it in the state diagram. But what is the difference here means we can represent the all states in input, whatever the input states we are having, that will be represented in circle notation. After that the transition will be represented from present state to next state, that is indicated by the directed lines through the connecting the circles. Okay. So present state to the next state, the transition will be indicated by directed lines, and also we can indicate the input and output values. Okay. So before the line we can represent it, that means before slash we can represent the input value, after slash you can represent the output value. So this is the state diagram. So totally what is the concept of analysis procedure? First they given one logic circuit diagram. So sequential logic circuit diagram they given. So first you should verify whether it is sequential or not. How to verify means feedback connection is there for flip-flop. Okay, that we will check it. Okay, and also where clock signal will be there or not, we have to check it. The 2 points you should first follow. So after that, verifying that clock is there and the feedback connection is there, then only we can say that that is a sequential circuit. So after verifying the logic circuit is sequential circuit, then we'll go with the second step, finding the input of equations of the flip-flop. So that means before the flip-flops, whatever the circuit you are connecting, combinational gates, so first you should find out that results. So that results we can call it as input equations. So after that we'll go with the third step, that is output equations. So how many outputs you are having, verify that. Without flip-flops, how many outputs you are having, just check it. Okay. So after getting the input and output equations, then we'll go with the step 4, that is state table. Okay. So input output equations means we are getting the Boolean expressions. So with the help of that Boolean expressions, you can find in the state table. Okay. So present state means how many inputs you are having, first verify. So based on that you should take it as binary combinations. You know this how to take the binary combinations. We have the 2 power n formula. So if you are having 2 inputs, 4 possibilities we are getting, 0 0 0 1 1 0 1 1. Okay. So whenever the input is 1, so you may take it as binary combination single, either 0 or 1. So after taking this present state and input, so next state how to find it means based on this Boolean equations you can find it next state value. Output also we have the expression, so substitute the input values in that formula, so you may get it as state table. So after getting the state table, what is the final thing, state diagram we will find it. So the state diagram will be found like this. So this is the analysis procedure we are having. Okay. So it's very important for long answer, don't miss this topic. Okay. Thank you.